Now we will proceed to our next question. We will proceed to our next question. And I want us to look at this question very fast. Let's see what you can get as the answer. So our next question, let me have a look at the question. What does it say? So our next question expects us to get the coordinates of M that serves as a point that divides a line PQ in the ratio 2 to 1. So we have this, our line. So this is our line, and our line is labeled PQ. And we are told that the coordinates of P in terms of the vector is -4, -2, and the coordinates of Q having vector Q are 5, then 4. Okay, we are told there's a point M that divides this PQ. So there's a point M here that divides PQ in the ratio 2 to 1. And you're told that these P and Q are position vectors. So we can be able to just complete this diagram so that you can have what you call a triangle. So this can be our origin. So we are told that we need to get the coordinates of M. How do you get the coordinates of M? There's something called the ratio theorem. What actually has to get done here? We shall have these two getting to that point of being able to have this as our vector, and one getting to that point of having this as our vector, which is vector P. So what do we do? Using the ratio theorem, we'll come here and then say ratio 2 out of the total ratio, which is 2 plus 1. That's 3 into that vector, which is 5, 4. The ratio theorem is normally used when you want to get the coordinates of a point that divides a line in a particular ratio. Look at this. I have point P and point Q. Point P and point Q are joined to give us a straight line. And there's a point M that divides that line in the ratio 2 to 1. The coordinates or the vector of P is -4, -2 for the value of x and the value of y. Then the coordinates of Q or vector Q will be 5, 4 in terms of the position vectors. So you're told to get the coordinates of M such that M now divides PQ in the ratio 2 to 1. Using the ratio theorem, just take this ratio, which is 2, out of the total ratio, which is 3. Then multiply by that vector, 5, 4. Then you shall say plus this other ratio, which is 1, out of the total ratio, which is 3. Then you multiply by this vector, which is -4, -2. So this is going to give you the coordinates of M. So let's open the brackets. 2 over 3 times 5, that gives us 10 over 3. Then 2 over 3 times 4, that gives us 8 over 3. When opening the brackets, please don't treat this as a fraction. Treat them as two very important parts of a vector. This is a column vector, so don't take this to be 5 over 4. No. So it will be 2 over 3 times 5. This 2 times 5, that is 10, 10 over 3. Then 2 times 4, that is 8, 8 over 3. Then you shall say plus 1 over 3 times 4, that is -4 over 3. 1 over 3 times -2, that is -2 over 3. So this will give us the coordinates of M. So let's start. 10 over 3 plus -4 over 3. That gives us 6 out of 3. And this will be 2. Then 8 over 3 plus -2 over 3. That still gives us 6 over 3, and that gives us 2. So the coordinates of M are 2, 2. So you can write it as a column vector, or you just write it as 2, 2. Those are the coordinates of M as a point that divides PQ in the ratio 2 to 1.